In this media, you will understand about construction, working, and phasor diagram of shaded pole type induction instrument. This instrument consists of disc, laminated electromagnet, permanent type damping magnet, spindle, jewel bearings, control spring, and pointer. The disc is made up of thin aluminum plate. The poles of the laminated electromagnet are split into 2 halves each. One half of each pole is encircled with thin copper band called copper shading bands. The spindle has a control spring and a pointer. The spindle is supported by jewel bearings. Control spring is attached to the spindle and it is used for controlling purposes. Pointer is connected with the spindle to show the readings directly. Damping is the process of reducing the oscillations of the pointer caused by the inertia of the moving system. This damping is achieved by placing a permanent magnet at the opposite edge of the disc from the laminated electromagnet. Single-phase supply is given to the laminated electromagnet through an exciting coil. An alternating magnetic flux is produced around the laminated electromagnet. This alternating flux induces current in the shaded portion of the electromagnet. This current induced in the shaded portion produces a flux phi sub 1. The magnetic flux produced in the unshaded portion of the electromagnet is phi sub 2. The shaded portion of the flux phi sub 1 is lagging by 40 to 50 degrees with the unshaded portion of the flux phi sub 2. The two alternating fluxes phi sub 1 and phi sub 2 induce 2 voltages V sub 1 and V sub 2 on the disc. These two induced voltages V sub 1 and V sub 2 create eddy currents I sub 1 and I sub 2 on the disc. These two eddy currents produce a deflecting torque on the disc. This deflecting torque is directly proportional to the square of the current to be measured, that is, T sub D is proportional to I squared. The disc rotates depending upon the residual torque between deflecting torque and the spring action and attains a balanced position. This position is graduated against the actual pointer reading of the parameter. When the disc rotates, it cuts the magnetic field generated by the permanent damping magnet. Hence, eddy current is induced in the disc, which interacts with the field of the damping magnet and produces a torque in the opposite direction to deflecting torque. Now you are going to see the phasor diagram of shaded pole type induction instrument. The vectorial sum of two magnetic fluxes, phi sub 1 and phi sub 2, gives the resultant magnetic flux phi. These two fluxes, phi sub 1 and phi sub 2, induce the voltages V sub 1 and V sub 2, which are in 90-degree phase shift with the fluxes phi sub 1 and phi sub 2 respectively. The two voltages V sub 1 and V sub 2 induce the eddy currents I sub 1 and I sub 2. Each eddy current is lagging by an angle alpha with the induced voltages. Thus, you have learnt about the construction, working, and phasor diagram of shaded pole type induction instrument.